Hello, everybody. Let's look at number 4. Once again, hopefully you've already read it and have recognized that there are two variables, two columns of data that you're going to be working with. One of them is the average hours of exercise each week, and the other is whether or not you use pain relievers like aspirin. So I have created a tab called number 4, and I've put those two columns of data in here. You want to do the same. Next, let's pick what kind of test we're doing. Well, there's 4 tests, and this is the 4th problem, so I guess it's kind of obvious. However, let's talk about why. There are 2 columns of data, so you know that it has to be one of these or it has to be one of these. We're going to use the chi-squared test for independence because one of our variables this time has 3 or more levels or categories, and that's this one right here. The time that you spend exercising, there's active, highly active, little activity, moderate activity, and there's actually a 5th one, which is no activity. Okay, so this is going to be a chi-square test for independence. We want to know whether these variables are associated with each other. Specifically, I'm thinking that if you are highly active, that might lead to a higher level of pain that you deal with, which might cause you to use aspirin, those kinds of pain relievers more often. All right. So with that in mind, let's go ahead. I think this time we're going to start with the hypotheses. So null hypothesis is going to be that exercise and pain relief are independent. Not sure why I'm capitalizing some things and not others. Exercise and pain relief are associated with each other, and our alpha will be equal to 0.05. Cool. So now we need our data to work with, right? And the way we're going to do that is we're going to highlight just the part of the spreadsheet that we need for the data. And then we're going to come here and do a pivot table. And let's do this on the existing sheet. And I would like to put it right there this time. Cool. For the rows, we're going to use the explanatory variable. Now, if there's an explanatory variable here, it's your exercise, right? Your exercise explains needing aspirin or Tylenol or Advil or Aleve or whatever. So that's going to go in the rows. We come here and we pick the same variable. I might stretch this out a little bit. Yes, indeedy do. And that's going to give me the count. Now, I want to go to the columns now and add columns that tell us about whether or not you use pain relievers. So there's our people that no, don't use pain relievers, and our people that yes, use pain relievers. Okay. So you can think of this as like, this is the observed table. What you want to do with this is construct an expected table. And the way that I go about doing that is I just copy these data, highlight these just so that they're easy to see. Okay, observed and expected. Cool. And then here for the expected one, I am going to delete all of that stuff. Will it let me? Oh, you know what I need to do? This is what I need to do. Let's delete you guys. I think what we want to do is copy it, but then right here, when we paste values only. All right, there we go. Now we've got it. Now, if we delete these, we are down to we need to fill in this space. So we want to match up these. Let's give you a little color with these right here. I'll give you a different color. Okay. So I want to see how these match up with this. And now let's take a look at this cell. These are people that are active and do not use aspirin. And if these two variables are independent of each other, what we're going to say is that there are 17 folks in this row. And of them, 19 out of 71 should say no. So we're going to get a number that looks like this. And then you can just keep doing that for each cell. Like for instance, for this one, you can go 17 times 52 divided by the 71, and that'll give you this. Or another option is right here. You can lock in the denominator because you always want that to be 71. And then you can set up, see where the 17 is? You want to make sure that both of these numbers right here get the 17, but then like the next row gets the 12. So basically you want the row to change, but you want the column to stay the same. So I am going to lock in, let's see, that's G17. So I'm going to lock in the G, but not the 17. And then for the other one, I'm going to lock in the E, but not the 22. You'll notice that when I copy this over here, I get the exact same value, and I can copy it all the way across. Now, if that blew your mind, ignore it. Don't worry about it. Just do them one at a time. All right. So there's our expected counts. Now, we do need to check the conditions on this guy. And one of the conditions is that the expected counts be all at least 5. So as I'm looking here, I see 1, 2, 3, 4 of them that are not 5. So we've actually failed the conditions. Because not all expected counts are 5. The truth is you can actually tolerate a couple of them not being 5, but this is too many. Okay, so that's technically at this point we should probably stop the test because our chi-square is not going to be 100% reliable. But I'm going to ask you to continue anyway. So now we go and we skip calculating chi-square for this. We just go straight to the p-value. Let me show you how. You go chi-square. And then right here, test. And you're going to highlight the observed data first, comma, the expected data second. Notice that I didn't do any of the margins, right? So I didn't do the totals over here in the columns or the totals here. You hit enter, and it gives you a p-value. Now we have quite a large p-value in this case, so that means that we would fail to reject the null hypothesis because our p-value is too big. There is not significant evidence that level of or exercise is associated with pain relievers. That's it.